Last time, we worked on controlling an LED. We were able to control the flashing frequency of the LED by using the digital write function and the delay function. Today, we're going to look at analog write versus digital write. So first, let's talk about analog and digital data. So analog data, unlike digital data, goes in waves, while digital data are discrete values. In terms of Arduinos, as you can see right here, for the output pins or the output input pins, as you can see here, the ones that are analog are the ones that have a little squiggly dash next to it. So here, number 3, 5, 6, 9, 10, 11. So we have 6 PWM. That's what we call PWM pins. And what PWM pins allow us to do is to send analog output to our devices. So in Arduino specifically, digital output or input basically goes into, there's like two options, right? There is high and there is low. As we talked about last time, when it is high, we turn the LED on, and when it is low, we turn it off. However, for analog output, we're able to control how much of the LED. So, similar to our last connection, let's connect the ground of the LED to the ground of the Arduino. Then, instead of going to a non-PWM pin, we connect the positive side of the LED to a pin where there's a squiggly dash. So right here, I'm going to work with number 11. Once you have done this, let's go to Arduino IDE. This is what we have from last time. So instead of number 8 on the Arduino board, we're going to update it to number 11. We're going to leave the pin mode the same because it still serves as an output to control the LED. For the loop, let's delete all of our code. We're going to replace digital write with analog write. And instead of going high or low, we're going to give it a specific value out of 255. So I am going to do, say, 255. Now, in order to see the difference in analog write, let's delay this. Let's delay this by 0.1 seconds. And copy this multiple times to see the difference of different values. So for here, I'm going to put 150, 150. Once you have done this, let's upload our code. We have successfully had this uploaded. And you might not be able to see clearly, but instead of flashing, this LED is shining at different times at different values. We can play around with this number, and I think if we delete all the delay functions, it would be easier to see how the value changes. So let's also add another line to analog write. It really doesn't matter, it depends on you. You can like put as many as you want. I just have 5, ranging from a value of 255 all the way to 0. And now, once that is done, as you can see, the LED's brightness is going up and down. So, now that we have been able to control the LED with the PWM output pin, let's learn to use something more interesting. Let me unplug this first. So this is a potentiometer. And what it allows us to do is to control the voltage from the analog output or input. So there's a turning turning mechanism here, and it allows us to control the voltage to high or low. And what this means is that instead of using our PWM pin as a output pin to control the brightness of our LED, what we can do is to let the Arduino take in the analog input or analog data from the potentiometer from the analog input pins here and control the LED in that way. So what you would need is a potentiometer, and you would also need 3 male-to-male jumper wires. So here I have with me 3 male-to-male jumper wires. It would make more sense if this one is red. So what we're going to do, we're going to put this potentiometer into our breadboard. So I'm going to put it right here. And as you can see, the potentiometer has 3 pins, right? So as you can see here, it is connected to the breadboard from 3 pins. Let's start from the left-hand side. So the first pin on the potentiometer is the ground. So simply same thing. Let's put the ground connected with the ground of the Arduino. So this is ground. The middle one is the analog input. This is where the value is sent. So in the middle should be this one. We're going to plug this in A0 of the Arduino. So A0 is at the left bottom corner. As you can see, A0. And finally, on the most right hand side, we have the VCC. Plug it into the 5 volts. And there you go. Now let's go back to our code. So we're going to add another new value, and this value is going to be the potentiometer's pin, right? So let's just call it like analog input, and that is A0. The LED remains 11. Then we're going to make an integer value that is 0. So we're going to add the pin mode for our analog input, and it serves as an input because obviously we're taking the input from the potentiometer to the Arduino rather than sending an output in analog to the potentiometer. Then inside of the loop function, we're going to learn a new function, and it is analog read command. So what we can do is to name the value, which is an integer, as what reading we get from the A0 pin from the analog input of the potentiometer. So let's do analog read. Then we can put in analog input, and that's it. So instead of writing it as a specific number, we're going to put value here. That means that whatever we read from the potentiometer, whatever we're going to shine, however we're going to shine the LED. Let's upload the code. I have to connect to the Arduino. Keep forget. All right, now let's connect or send. Nice. So now As you can see, the LED is not turned on yet. But as I start twisting the potentiometer, it goes brighter and brighter until it reaches the highest, and then it just goes from 0 again. Let's see again. It goes dim, dim, dim. It goes in a cycle. So what I can do to address this is perhaps divide that by 3. Let's try again. Not quite, but we have now it's just like 2 increments. As you can see, this works, and if I turn this, it goes brighter, 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 and I turn back, it goes dimmer, 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 and dimmer. And how this is working, again, the Arduino is getting the input from the potentiometer, which is based on how much you turn this. And this input, which comes in an analog value, is read by the Arduino. And we're taking in this value to be set as the value of the brightness of the LED.